That's your quiz today. 2 problems, a drafting question, and a write the equation of a line that's either going to be parallel or perpendicular to the given line to the given point. Slope intercept form, but then you got to switch it over to function notation. So if you didn't open it up and print it or work it out, we're going to work it out right now. Now, normally I would have a copy for you and have it printed so you could have a copy and do it right now. But for some unknown reason, there's no paper in the school. Don't know why. But fortunately, I was able to copy off your quizzes. I know you're so thrilled. No, again, the questions are going to be just like this. So you need 2 points and a straight edge to graph your line. Put your arrows. 2 points. When you have function notation, it is automatically in slope intercept form. So you automatically already have everything you want. You don't have to solve for y. Because function notation, this f of x equals -2/3 times x plus 5. That f of x is right here, and function notation replaces y. So this is exactly the same as y equals -2/3 times x plus 5 when it's in function notation. So since it's already in function notation, we have already our y equals m times x plus b. Trying to weed through the many pins. And by the way, another thing, there doesn't seem to be any pins on campus either, except red. And most of the red pins, they don't work so well. So. I know you guys have your own troubles. These are my troubles. I'm sorry. I'm thankful. So what you need to do, just step by step, every time I'm doing the same thing. And that's how you practice repetition. In order to graph my line, I want 2 points. The y-intercept is where I start, and then the slope tells me how to get to the next point. My slope is the coefficient in front of the x. If there's no x here on the right-hand side, then you don't have a slope. In other words, if all you saw was y equal -2/3, you wouldn't have 2 terms, by the way. Because if you had y equals -2/3 plus 5, then we should have added those together because they're like terms. If you don't have an x over here, that is not the slope. That is your y-intercept. And it's horizontal anyway, because when you have only y by itself, special case, horizontal. When you have an x, the coefficient, that's your slope, -2/3. The constant that comes after the x, that's the b, that's the y-intercept. The first point to plot is the y-intercept. Now remember, the y-intercept is on the y-axis. It's on the y-axis at +5. So some of you were putting on your test, you put your y-intercept on the x-axis. X is left to right. The y-axis is horizontal or vertical, up and down. So up here at 1, 2, 3, 4, 5. There's my first point, and you only need to label it with one single number. It's like labeling a number line. If you label it with its ordered pair, make sure you do it correctly. If you're going to label this with an ordered pair, it's x is 0, y is 5. Because on the y-axis, the ordered pair left and right, you go 0 left and right, and then you go 5 up. Not 5, 0. 5, 0 is over here. The other thing, and this was better than the quiz, but you never put parentheses around a single number. You only use parentheses when you have your ordered pair. So there's my first point. The slope tells you how to get from one point to the next point. The slope is directions on how to go from one place to the next place. Now, the slope, the negative is right in front of the fraction like this. And as I keep telling you, my preference is to put my negatives, if I have a negative slope, I prefer to put my slope in the numerator and keep my denominator always a positive. It's rise over run, rise over run. So my numerator is either going to be a positive or a negative. So my first move is either going to go up or down, up or down. But my second move, the run, since I'm going to keep my denominator always positive, my run is always going to go to the right. Always to the right, because I'm keeping the denominator positive. So if I have a positive slope, it would be a positive over positive. I go up and to the right. Oops, your right is that way. Up and to the right. If my slope is negative, then I'm going to go down and then to the right. So the next point on the line, starting from here, I go down 1, 2, and then I'm going to go over 1, 2, 3. This is where the next point on the line is. Now you need to label that point's coordinates, not the slope. You label the location of that point, the address of the point. Not how you got there, but where are you? So ordered pair, right here, the x is a 3, and the y up here is a 3. It goes to that point 3, 3. Okay? And to stay on the line, the slope is always down 2 over 3. If I went down 2 and over 3 more, down 1, 2, over 1, 2, 3, the next nice point to plot would be right there. That ordered pair would have been x is 5, sorry about that, x is 6, and y is positive 1. You only need to give me 2 points. So any 2 out of those 3, perfectly fine. If you prefer, because you want to be different, no problem. You could make it a positive 2 over a negative 3, which means the rise is positive, but the run is negative. So you're going to go up, and the denominator is negative, you have to go left. So I could go up 1, 2, and then I would go to the left 1, 2, 3. The location of that point, x is negative 3, y is a positive 7. And as you can see, all of those if I graph my line through any of those 2 points, They are all on the same line. Okay. Any two. Don't try to grab more than two, because what if you make a mistake on the third one? What does it mean if you're on the line? That means if you plug in the x coordinate, you're supposed to get this y coordinate that comes out. If I go f of 6, the y answer is a 1. I'm supposed to get 1 when I plug in the 6. So let's see. F of 6 means replace this x with a 6. If I replace that with a 6, I replace this with a 6. So it would be negative 2/3 times this x is now a 6, and then plus 5. A negative times a positive would be a negative. So that's going to be a negative. 3 goes into 6 2 times. So you're left with negative 2 times positive 2. So there's a negative 4 plus 5. So f of 6, negative 4 plus 5 equals positive 1. When I plug in negative 3, the answer is supposed to be 7. When I replace x with negative 3, then the y value is a 7. So let's go plug in negative 3, f of negative 3. And you don't need to do what I'm showing you right now. You don't. I'm just showing you what's going on. So equals negative 2/3, negative, and then 2/3. And then I'm replacing this x with a negative 3. So times negative 3, and then a plus 5. So f of negative 3 is equal to a negative times a negative is going to be a positive. This 3 goes into that 3 1 time. So you basically are left with negative 2 times negative 1 is positive 2, and then plus that 5. So f of negative 3 is equal to positive 7. When I plug negative 3 in for x, the y value is a 7. Like it's supposed to. The picture, the graph, is basically a picture of all the possible answers. Every single ordered pair that makes this graph work. Remember, it's an x and a y. It's all of the x's and y's that would make this equation a true equation. Okay? That's what's going on when we graph. It gives you all the possible solutions for the x and y that make it work. And there's an infinite number of them when you do graphs. You can either sit down and write out an infinite number of answers, or you draw a picture. Okay. The second question. So that's the first question, Nick. Draw the graph. The second question. Write the equation of the line described using function notation. Now, the first part right here, this last part, using function notation, g of x. So that means when I'm done writing my equation in slope-intercept form, my y equals mx plus b. At the very end, replace y with g of x. Because you're supposed to write it using function notation. On the homework, they had it typed in for you. You didn't actually have to do it by hand. On the quiz, on the test, it's going to say, write your final answer using whatever of x. Make sure you use the correct name of the function. If it says f of x, you're going to call it f of x. If it says g of x, you're going to call your final answer g of x. If this said h of x, then you would call your final answer h of x. If it said t of x, then you would call your final answer t of x. Whatever the directions tell you, make sure you follow the direction. Okay? Don't lose a silly point because you didn't follow the direction. So my final answer, basically, I might just go down here. What does g of x equal? Because I'm not going to have that typed in for you. So it's kind of like, all right, first thing I read, I know I'm going to need to put g of x down there. I got that ready to go. Now, if possible, the only kind of graph you cannot write using function notation is vertical lines. If it's vertical, that's a special case. The function notation, f of x, g of x, h, whatever function notation, only replaces y. Vertical lines are x equals a number, x equals a constant. Function notation won't replace x equals. So if your line is a vertical line, that's the special case. Write the equation of the line using function notation if possible. If the function notation is not possible, use the appropriate special case notation. So you would just use what does x equal because it's a vertical line. That's the only time you need to concern yourself. How would you know? The slope is undefined. Or if you know that it's vertical. Okay. Our line is going through this ordered pair of 15, -5, and it's perpendicular to this line. So what I need, and I'm just setting this up and getting it ready to go. I need, step one, I need slope, but my slope is perpendicular slope. So right away, I want perpendicular. So the slope of my line is the opposite and reciprocal to the other line. That's perpendicular. If I asked you for parallel, then I would want the same slope, equal slope. Just like the two warm-up problems we did on Tuesday. We did one that was parallel, we did one that was perpendicular. Your quiz today, it might be parallel, it could be perpendicular. Okay. On Tuesday, okay, we had to solve for the slope. We had to figure out what the slope was, because I didn't give it to you. On your test in chapter 3, I gave it to you. I gave you y equals mx plus b star. So now, because we're all grown up, we need the slope of this line. Remember, this is just like that, my sophomore year when that girl wanted to just go to formal. I took her to formal and then she got rid of it. Okay. We're going to take this line out to Christmas formal. Once we get it sloped, we're getting rid of it. We don't need it anymore. We won't use anything from it. So over here, I want it sloped. You heard of gold diggers? Well, we're slope diggers. Okay. Sugar daddies, sugar mamas, whatever you want. My son has a sugar mom. Okay. My daughter-in-law is a school psychologist. Master's degree, she makes a good living. My son, he is a vet tech, but he's happy. I mean, he graduated with a 4.15, all sorts of honors. Went to UCLA, aerospace, or not UCLA, but Cal Poly San Francisco, aerospace engineering. Hated it. Left school. Started working a regular job. Then he, after about 8 years, hated that. What did he like? I like dogs. So then he went to San Joaquin Valley College and worked on his vet tech. And my daughter says, you know what? You come home smiling. I'll trade that. I always told my calculus students, there's two ways to approach life. You either get to go to work in the morning or you have to go to work in the morning. That's a choice. Sometimes in a job, yeah, it's always get to or have to go. I get to go. Okay. Don't know how I ended up here. I guess it was because when I got cut by the basketball when I was 14 years old. But I've been doing this over 30 years. I've been doing this over 30 years, and I'm only 50. And now we don't look. Body is the way it's set. Right. We need y equals mx plus b if we're going to get some. So, all right. You're going to start losing points if you do this. I want y by itself. I want y equals mx plus b. And how are you supposed to remember that? Oh, look over here. That's what you want, so you can figure out something. You got to put x on the other side. Some of you on your test, you just did this. 9x minus 9 does not undo the 9x. 9x minus 9, they're not like terms. What you now have on the left-hand side, you have 9x plus 12y, and then you have a minus 9 equals 48 minus 9 is 39. You cannot go 9x minus 9 and then undo the 9x because it's not a 9, it's not an x. If you mean to undo that positive 9x, then you need to subtract 9x from both sides. Details matter, and eventually it will catch up with you because you're going to think you can actually do something that you're not supposed to do, and that's just not, it's not right. And if somebody would have fixed those details in your past and held you accountable for it, maybe it would be a different place where you're at now. Okay, that's why I'm not to be a jerk, but I'm trying to help you make sure we don't keep making mistakes. Okay, so now we have, and one other thing. Some people were going like this, minus 9x, minus 9x. So now that's not going to work because on the left-hand side, you took 18 x's away from the left-hand side. Negative 9x and negative 9x, that's negative 18x on the left. On the right, you only took away 9x's. You have an unbalanced equation. You can't, if you have two kids, and you give one of them 10 pieces of candy, so don't give the other one 5, you're going to have problems with those two kids. Not fair. It's not equal. How come you like Campbell better than her, better than the other one? You got to do whatever you do the left, you got to do the right. What you're confusing it with is when you do multiplication or division. When you do multiplication or division, that's when you do the same thing to each one, not addition and subtraction. Addition and subtraction is like when you have a balance weight. If you take two, if you take 3 pounds off of one side of the balance weight, that goes down, this one will go up. Or, you know what, even better. You guys know what a seesaw teeter-totter is? Whatever happens when your friend gets off without, boom, okay? Not fair. If you take one person off of one side, but not both, it's not balanced. Whatever you do with addition or subtraction, you have to do it same side, same amount. All right. So that cancels, that's a 0. So now all you have is 12y equal to, now remember, we like the x and then the constant. So the x, negative 9x, and then a plus 48. I'm giving it away. I'm giving this away, so be aware of this for the quiz today. On today's quiz, that will be a negative. So when you bring this down, don't forget to bring the negative with it. It will be a negative when you do the quiz today. The next move would make sure you divide everybody by a negative and keep the negative 12 and keep track of that negative. A negative over a negative over here, that would be a positive. A positive over a negative, that would be a negative. So be careful. On the warm up, it's a plus. So that's a positive 12y, negative 9x plus 48. So to undo this multiplication, we divide everybody by 12. So there's y equals. Now, I keep telling you guys, simplify, reduce fractions, reduce your fractions. A negative over a positive is going to be a negative. 9 is 3 times 3. 12 is 3 times 4. And then you have the x. And then plus 48 and 12. 12 goes into 48 evenly. So that's 12 times 4. And this is 12 times 1. So what you have left over here is y equals a negative. The 3's reduce, it's negative 3 over 4x plus the 12's reduced, so you have 4 over 1. 4 divided by 1 is just 4. That's the equation of the line we don't care about. But what we do need from it, that's the equation of me as a sophomore, the girl who didn't care about me and dumped me when she got to the Christmas formal. So all the day she wanted from me was Christmas formal. All we care about over here is this line's slope. The slope of this line is negative 3 over 4. That's all we're using it for. And honestly, I am over that whole sophomore year thing, but it's just an analogy, okay? Perpendicular. Slope of a perpendicular is opposite and reciprocal. You change the sign no matter what. If your slope was, if the one line was positive, opposite means it's negative. If this slope is negative, then perpendicular is positive. You change the sign. Reciprocal, you have to flip it. So what is the slope of our perpendicular line? Positive 4 over 3. So that's negative. So my slope for perpendicular is positive. That's 3 over 4. Flip it, it's 4 over 3. That's our slope. Okay, opposite, reciprocal, perpendicular. That's all we need. We're now done with this completely. Okay. So now we do find the equation of the line. Step 1, find the slope. I got my slope, 4/3. Next step, is it a special case? Nope, it's not 0, it's not undefined, not a special case. So the next step, write down the equation y equals mx plus b. Because that's what we're trying to fill in. You got to find the m and the b. Well, good news, we already found the m. We have y equals 4 over 3 times x. Now, the last piece of the puzzle, you got to figure out what b is. On the test that you guys took, some of you just went ahead and plugged that b into over here. Remember, we're done with this. We don't use anything else but its slope. You got to use this point. If you didn't use this point, then you messed up something because you're supposed to go through this point. So now to figure out the y-intercept, we're going to use this x and y here and here and figure out the b. So on this point, we're going to let the x equal 15 and the y is a -5. Make sure you copy them down correctly. That's another mistake some people are making, is they're not copying down and plugging in the right things. So going in for y is -5 equals 4/3 times x, so times 15, and we're solving for the b plus b. You got too many colors. Right. Remember what I promised you. Your slope times the x that you plug in should reduce nicely. If it doesn't reduce nicely, then you might have made a mistake on the slope, or maybe you put the y where the x should have gone. If you're having trouble, come up and ask. I can't tell you the answer, but I might be able to direct you to the answer. Look how this simplifies. -5. 3 goes into 15 5 times. 4 times 5 is 20. Plus b. And then to solve for the b, subtract 20. -5 take away 20 is -25, and that's the y-intercept. So the missing piece of the puzzle, the y-intercept that we needed to find, is a -25. So the equation y equals 4/3 x, and then plus -25 is -25. And then you're probably going, all right, I get it. And then don't forget function notation. The directions want the final answer for section 8.1 using function notation. This one asks for g of x, so you're just going to replace this y with g of x instead. So we get g of x equals 4/3 times x minus 25. That is exactly how it's done on today's quiz. That's exactly how I showed you the mock-up of the chapter 8-9 test. That's exactly how the first question on your chapter 8-9 test is going to be done. And again, it's either going to be parallel or perpendicular. Okay. Before we do 8.2/8.3, now it says 8.2/8.3 because we're going to kind of overlap a little bit and see how that works out. Before, is there any questions from 8.1's homework? We already did a lot of examples. The lecture's already finished, but is there any questions for those of you that actually did the homework? Okay. I really meant to give you quite a few handouts today. And because I was not able to print anything or print one, I hope to have them printed for you on Tuesday. But I will post them. I will show you what I meant to give you, and I will post them in the announcements. I'll probably email them to you as well. The first few we're just going to go ahead and do because they're very strict. One of the things about math, in any class you take, you have to be able to read a graph. So in other words, you got to understand the connection between all the parts and what it means when you're on a graph. Time I keep enlarging this. Oh, this is not working. Sometimes it hasn't been coming. In question number one, the question is, what does f of 2? That's all they want. What is f of 2? And it says, use the graph. It doesn't give you an equation. It doesn't give you something to just plug 2 into. It says, use the graph. Remember what this means. Functions are ordered pairs. 2 is the domain. 2 goes in for the x. The function notation is the answer for the y coordinate. So the answer for the y coordinate is, and it gives you a solid point right there. When 2 goes in for x on this graph, what is the y coordinate at that point? It's a 2. So if the ordered pair, if x is 2 and y is 2, then f of 2, the answer is 2. So you're just looking at ordered pairs. Function notation is ordered pairs. Now, that's not a great problem because the answer was 2. So let me do a similar question, see if we can do something good. They're asking for f of 2 again, but at least they moved it. So now in this picture, when x is 2, here's the point on the graph. So here's the x is 2. What's the y value right here on this graph? It's 1 up, so the y is a 1. So the ordered pair, when 2 goes in for the x, 1 came out for the y, so f of 2 goes in for x. That means the answer came out in the graph. The answer is 1. That's all. And we actually did a little bit of this in 3.6. Okay, this one's asking for f of 3. So on the graph, when you go to x equals 3, what's this y value that goes with it? At that ordered pair, when x is a 3, the y is a -3. So when you plug 3 into the function, -3 comes out. If only they were all like this. And then they turn it on you, just when you thought life was going well. Okay. The question is now switched. It says use the graph of the given function f of x to find x. What does x equal? What does x equal? On questions 1 and 2, they wanted to know what was f of some number equal to. So they gave you the x coordinate, they gave you a number for x, and you had to figure out what the y was. Now they're giving you, in this problem, f of x is equal to 2. So they're giving you the y coordinate. You're supposed to find the x coordinate. So they are changing the order of the question. It's like Jeopardy. In questions 1 and 2, they were asking you, what was f of 3? What was f of 2? So that's the question. Now this is Jeopardy. They're giving you the answer. You got to come up with the question. F of some number, the answer is 2. So what's the question? What is the x equal? That's what you do. So the picture. You now look at the y values, and right here, here is a y value that's a 2. What is the x that makes that 2 happen? 1. The ordered pair is at 1, 2, so that means we must have plugged 1 in for the x. F of 1 made the 2 happen. That's all you're doing there. All right. This is one of the handouts I wanted to make for you. So what I'm going to do is I'm going to have to post it for you. And you can print it out on your own, but I'll try to have copies for you as well. It would have made copies. It was going to make copies, but then it didn't make copies. Show you what I was going to give you. Perfect squares for the numbers 1 through 15. Because the next few questions, we're going to take square roots. So I have made this table that I was going to print on the back of this table. Okay. So let me show you what I'm talking about. This goes all the way up to 15. And these are just the perfect squares. The table for the exponents. Okay. Bases are on the far left column, and it goes all the way to 25. And then the exponents. 1 to the 0, 1 to the 1, 1 squared, all the way, 1 to the 10. 2 to the 0, 2 to the first, 2 to the second, 2 to the third, all the way to 2 to the 10. 3 to the 0, all the way to 3 to the 10. 4 to the 0, all the way to 4 to the 8. Okay. 5 to the 0, all the way to 5 to the 6. 6 to the 0, all the way to 6 to the 4. Because a lot of these other ones, you know, it's great if you know them, but you can always use a calculator. These other ones happen so often. Well, definitely the 2. 3, not so much. 3 might happen at least to about 3 to the 5th. A lot. Sometimes 3 to the 6th. 4 will happen quite a bit. At least 5 to the 5th, maybe sometimes 5 or 6. I just went one more. But these, you don't get a whole lot of these. Now, powers of 10 all the way across because that's easy. And as you can see, When you go down 11 on, it's just powers of 2, the squares. The farthest it goes is squares. So 17 to the second, 18 squared, 19 squared, so on. Except for 20, here at 20 goes all the way 20 to the 10th, because if you can do 2 to the 10th and you can do 10 to the 10th, and you can do 20 to the 10th. Okay, because they're the factors. I have that copied. It's not homework. If you know your powers, not just on a calculator, but you know them I'm not saying by heart, but if you know them, you're familiar with them, you don't need a calculator to do them. It's going to make chapter 10 and chapter 12 so much easier. It's going to make chapter 8 and 9 a little easier, because in chapter 8 and 9, we're going to be dealing with squares. That's why I made the special one with just squares. Now, we don't need to know a lot of squares, but I wanted to get started on squares. In chapter 10, we deal with square roots and cube roots and fourth roots and fifth roots. That's why if you know your powers for those, x to the third and x to the fourth, then you can do the cube root and the fourth root and the fifth root. If you can go one way, you can go the other way. So I made this table so you could start working and filling these things in. Not memorizing, but just get familiar and start to know some of these. You know, like I know 2 to the 9th is equal to 512. Okay, 2 to the 8th is equal to 268. 2 to the 10th, that was 24. I know my 2 is real simple, because you just double. Everything to the 0 power is 1. 5 to 0, 1. 12 to 0, 1. 1,000 to the 0, 1. That's one of the rules of exponents. Now, when do you get rules of exponents? In Algebra 1. The class we don't teach before this class anymore. But I also printed out the rules of exponents that I'm going to make a copy for, and I'm going to post. Because you're going to come across, come on, where are you? And again, I couldn't make copies because there's no paper in the copy machine. There you are. In chapter 5 of this textbook, you learn 8 rules of exponents. In this test, one of the bonus questions is the rules of exponents. Bonus question. In chapter 10, it's all about exponents. From chapter 5, there's only 8 of them. In chapter 10, we're going to get 2 more. There's going to be 10 total rules of exponents. So I'll post this over the weekend. You can print it out if you want, but I'll have copies made by next week. Okay? That way you can start reviewing. You need to know the rules of exponents. Because some of you are going to want to know, how did you get that? And I'm saying it's one of the rules of exponents. We hand this out. And because I was not able to make all the copies of the 1 through 15, because these are just the perfect squares. And for this particular chapter 8 and 9, your perfect squares is what you really want to know. And you don't need to know a whole bunch of them, but I wanted to get you a good start. This one that I'm handing out to you right now, the perfect squares are this column right here where the powers of 2. So you can still do 1 through 15 on this one. And then, like I said, I will post this one and I'll have copies for you next week. So here's this one, the other one. And you know what? I would have had these 2. And I put them in the copier, and I said I want it back to back. And It didn't print both sides. It only printed one page. It only printed this one. And I did it twice. I tried. Don't tell the other professors, teachers that I used every piece of paper that was in the machine that was left over. Pass one down and then to the front. So I left the copy machine empty. Again, it's not mandatory, but you do get to use it on quizzes, and yeah, it's just good practice. So for this particular exponent of power 2, okay, let's just start with the power 2. And we're starting with 2, 1 squared. So 1 times 1. Not going to be able to fit everything here, unfortunately. So I'll do it side by side. I need 15 on this small side. So in the column with the 2, 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3. 3 times 3, 9. 4 squared, 4 times 4, 16. 5 to the second, 5 squared, 25. 6 to the second, 36. 7 to the second, 49. 8 to the second, 64. 9 squared, 81. 10 squared, 100. 10 times 10 is 100. Now, here's what I want to point out with the 10, why it goes all the way across. Whatever your exponent is, that's how many zeros you put on the 10, or on basically a 1 followed that many, a 1 followed by that many zeros. 10 to the first is a 1 with 1 0. Everything to the first is itself. 10 to the first is a 1 with 1 0. 10 to the 0 would be a 1 with 0 zeros, no zeros after it. And that is something that we will talk about. Everything to the 0 power is a 1. 6 to the 0, always 1. 7 to the 0, 1. 8 to the 0, going to be a 1. That's something we'll cover later. But 10 to the 0, 1. So that means 10 to the third is a 1 with 3 zeros. It's 1,000. 10 to the fourth would be 10,000. That's 4 zeros. 10 to the fifth is going to be 100,000, 5 zeros, and so on. So that's why when we get over here, 10 to the 10th would just be a 1 with 10 zeros. Okay? That's why I put it on there. I don't expect you to multiply 10 times 10 times 10 times. I wanted you to see that there is a nice pattern about tens. 11 squared is 121. 12 squared, 144. Now, does anybody know what a peachy folder is? Okay. Actually, it's called an OPG folder, but we just call it peachy folder growing up. Peachy folder was just a folder that we put our papers in. And we didn't have the whole traffic folder. We didn't have all. in one of the little flaps in the very top right-hand corner was a times table. And it went to 12 by 12. So 12 times 12 was the biggest number that we had, 124. And it was just a nice reference because, hey, not everybody had a calculator when I was a kid. And of course, we weren't allowed to use it. I know some friends that just cut them out and had them real small. But your multiplication tables usually go to about 12 times 12. But you will see these numbers a lot when you do math. You're going to see lots and lots of these squares that happen all the time. 13 to the second is 169. 14 to the second is 196. And the last one that I think you should really pay attention to for right now, 15 to the second is equal to 225. Sixteen to the second, 256, 17 to the second, 289, 18 to the second, 324, 19 to the second, 351, 20 to the second, 400, 21 to the second, 441, 22 to the second, 484, 23 to the second. Oh, I never remember that one right. 24 to the second is 24 to the second is 576. 25 is 625. And here, they're just asking you what's the square root of 4. So if you know what you can square to make a 4, what they're asking you when you do square root 4 is they're asking you what number to the second power actually equals a 4? What can you square that makes a 4 inside the square root? So right here, I get a 4 when I square the 2. So the square root of 4 is a 2. That's what they want, square root of 4 is 2. Oh no. Behold the fraction. Negative square root 49 over 121. Well, the negative means my answer is going to be negative. Look at it like this. They're asking us for the opposite of this answer, the opposite of square root 49 over 121. So that just means bring the negative down. Now, when you do a square root, we're trying to figure out what times itself, the exact thing times itself, gives me a fraction of 49 over 121. When you look at a fraction, you have a numerator times numerator, a denominator times denominator. That's how you multiply fractions together. You go straight across. The numerator is 49. So what times itself makes 49? 7 times 7. So 49 is 7 times 7. And 121, what times what makes 121? 11 times 11, because you now got this over here. 11 to the second is 121. So now you know, basically you got this negative, and you got the square root of this 7 over 11 times itself. So there's a negative on the outside, so my answer is going to be a negative. The square root of 49 over 121 is just one of those 7 over 11. What times itself? 7 over 11 times 7 over 11. 7 11 times itself. But it's negative because the negative is on the outside of the radical. It's asking the opposite of this answer. So the opposite of square root 49 over 121 is the opposite of 7 over 11. Negative 7 over 11. What's square root 36? 6. And I know you're going to be tempted to punch it up on a calculator. Try not to. Wow. The next one is exactly square root 36 again. Okay. So let me do 6. And let me ask for a different question. Somewhere. Square root 4 we already did. That's a 2. All right, let's move on. All right, good. And I'm going to leave this one up here. So this was question number 2. Here's question, or was it number 2? I don't even know. Here's number 8. Square root of negative 121. What's the difference between those two questions? The negative. On the first one, the negative is outside of the radical. On the second one, the number's on the inside of the radical. So I know the square root of 121, 11 times 11. 11 times 11. Square root is asking me what number times exactly itself, what times itself equals the inside. So I know 11 times the 11 would give me the 121, but it's supposed to be a negative. So the only way to make a negative is a positive times a negative. Because a positive times a positive is not negative. So to get a positive, to get a negative, I need a positive times a negative. But if I do that, positive 11 and negative 11 are no longer the same number. If you have $11, so if you win $11 and you lose $11, that's not the same thing. They're not the same number. Square roots, you have to have exactly the same number. So that's not going to do a square root. If I go 2 positives, that's not negative square root or 121. If I do 2 negative 11s, what's that equal? Positive 121. I don't want positive, I want negative 121. So that doesn't work. So it's either 2 positive 11s, which doesn't work. 2 negative 11, that doesn't work. You can't have different signs, that doesn't work. Those are the only options. Nothing works. Oh, wait, this multiple choice question. The answer is, or the square root is not a real number. There is no real number that makes this work. That's a little foreshadowing of chapter 10. You can't take the square root of a negative number and get a real number. There's no real number that makes this work. So in chapter 10, if we can't do it with real numbers, there must be some other kind of number that we just haven't come across yet. Okay, and if some of you know what I'm talking about, then you know we're talking about things that if they ain't real, they're like the friends I grew up with. They're mad. This is not a real number. Okay. The reason why we did all those square roots is because now we are going to embark on graphing. And we are going to graph these things. We're going to graph. Well, first of all, we are going to graph still y equals mx plus b lines. We're going to graph y equals A times, parentheses, X minus H squared plus K's. We're going to graph Y equals A times the absolute value of X minus H plus K's. And we're going to graph Y equals A times the square root of X minus H and then a plus K. You're going to learn how to graph squares, absolute values, and square root functions. Now, if you notice, they all have A's, they all have H's, they all have K's. So those A's, H's, and K's must be telling us something about those graphs, and they're going to tell us the exact same thing. Homework on oh my God. You're also going to graph things that look like this, piecewise functions. So you got something there for X, something here, for X, something here. Piecewise. Not piecewise, not piece, but pieces. One piece at a time. So we're going to come back from break and we'll talk about our first kind. We're not going to do the homework yet. We're going to take it apart one piece at a time. And what we've got to do, whenever you learn how to graph something, you plot some numbers, you plot some points, then you see the pattern, and then you don't have to plot points in for the most part. So let's come on back at 47. This gives us the breakdown to set up a table, graphing. When you graph something brand new, you want to make a table. So. Over here. Whoa. So, quiz today, and I'm gonna let you start at 10:30. So I give you 15 minutes to do the two problems. Continue with 8-2, 8-3 on Tuesday next week, and hopefully start 9-1. We don't start 9-1 here. And as you can see, 9-1 and 9-4. Well, that's the hope. Okay. Maybe it's a new hope. I don't know. March 1st. Okay. 9-4 and the review sheet for chapter 8-9. We'll see. Again, this is all movable by active. On March 1st, you're going to take a quiz on these two sections, 8.2 and 8.3. March 3rd, I'll give you the quizzes back. Review chapter 8-9, March 8th, chapter 8-9-10. Now, that quiz you're going to take looks exactly like this. Graph and label, this is an old version. Graph and label the following functions. 2 points are necessary when you graph a linear, a line function. All the other functions may require at least 3. So you have to have a minimum of 3 or more for accuracy. And there's the favorite word, symmetry. 5 questions, they are 10 points each. Five questions, 10 points each. Now, prior to that quiz, you're going to get, I know it's here somewhere. Don't put that in there. Well, okay, I don't have it out, of course. I'm opening up 1,000 things. I can't keep track of anything. So look real quick, if I don't see it in this first spot, then I'm gonna just show you. There it is. So I'm going to give you a practice of the quiz as a homework, not a homework to turn in, but take. Hey, here's like a review sheet for your quiz. You can choose to do it or not choose to do it, but when you take your quiz, you're going to see one of each of these graphing questions. You see there's 5 things over there. There's 5 questions over here. And it'll get scrambled, not in the same order. That's the one with the power of 2. There's the absolute value. That's this one. Oh, what is this? What? Well, what we've done, lines, linear equations. Okay. Square roots. And then the Reese's Pieces, piecewise functions. No surprises. Come on, you know me. All right. So you'll have that before back to the graphing. And what we call these first things that we're going to learn how to graph. And we probably are only going to get through parabolas and maybe square roots today. We'll do the talking this week. Parabolas and absolute values today as a whole. Square roots and piecewise on Tuesday next week. But what you're going to learn how to do first is they're called the parent graphs, or also known as the parent function. And I know I'm not on screen for everything. I'm not even on screen right now. Okay. So what a parent function is, it's basically like a cheese pizza. Pizza with no toppings. I gave you everything that you're going to need to be able to do in terms of the most it's going to have. A's, H's, and K's. The parent functions, and right now just the ones we don't know how to do yet, y equals just simple x to the second. Just y equals x to the second. No a in front of it. Well, technically there is an a, but we'll get to that. No h inside of a parentheses. No k afterwards. Just a nice simple y equals an absolute value of an x. So no visible a right in front of it. There is one there. We'll talk about it later. No inside. There's no h being added or subtracted from it. And there's no number k afterwards being added or subtracted. Now, when I say added and subtracted, it's like, what are you talking about? Those have pluses. Well, if you add a negative, that would be subtraction. Okay. And then just a simple y equals just a square root of x. Okay. Nothing inside, nothing afterwards, right now in front of it. Don't worry about that in a minute. The goal is to figure out what the parent graph looks like, and then we learn how it's going to be manipulated, how it's going to shift, translate left and right. Basically, is it going to flip up or down? Is it going to get wider? Is it going to get narrower? And all of those things, that's what A, H, and K control. They all have a part to play. So what we're going to be working on right now is all of the pieces for the first one, y equals a times x minus h parentheses and then the square, and then afterwards comes the plus k. And right now you're just looking at just simple x squared. Remember, I've used that analogy about the police lineup, and you want to line up the things so you know what, the M, the X, sorry, the M and the B are. You want to put things in the same order so things have purpose. So let's just take a quick comparison. Y equals a parentheses x minus h to the second power, and then plus k is where we're headed. And right now, all you're looking at is just simple y equals just x squared. But right here in this parent function, there is an h, there's an a, there's an h, and there's a k. There is an a, h, and k. No matter what, there's always going to be an a, h, and a k. Always. Let me show you. How many x squared do you have? No, that's x to the second. How many of them are there? Just one. 1 times x squared is just x squared, isn't it? We don't leave 1 times x squared, but there's a 1 in front of that x squared. Okay, there's a 1 times the x squared. We don't put the 1 because you've got to simplify. 1 times x squared is just x squared. So if you don't see something in front of the x squared, that means there's a 1 right there in front of it. So actually, my dad was a roofer for 25 years. That's how he put all of us through private school, 6 kids. Sacred Heart, which doesn't exist anymore, but you guys know about St. Joseph, Sacred Heart was the other, Fresno. Sacred Heart, St. Helens, St. Anthony's, OPH, OLD, blah, 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 blah. Anyway, then he sent all 6 kids to San Joaquin Memorial. He worked his tail off. But anyway, his hands and arms were burnt, scarred up, burnt, because he was basically roofing for Fresno Roofing. They did commercial job, hot tar. He would hot mop, bruise, and burn his skin. I mean, but he did that so we'd have an education. He barely made it through the 8th grade when he was in school. He was born 1917, so he was 50 when I was just surprised. Well, people say accident, I was surprised. Anyway, he did all that hard labor, so I wouldn't go home with scars and, I go home with ink on my hands. Whenever I wash my hands at the end of the day, I'm going, thanks, Dad. Now, I know my back is killing me, but still. So there's a 1 times that x squared. So you're looking at really 1 times that x squared. Now, parentheses. Do you see a parentheses here? So inside the parentheses, there is x minus a number before you square it. There is something because there's always going to be something. What number would you subtract from x that leaves the answer x? X minus what number is equal to itself? Give you a hint. 5 minus what number equals just 5? I heard 1, 5 minus 1 is 4, so that's not it. So it's 0. 5 minus 0 is your 5. So in here, x minus 0 is how you make x. So what's in here? There's a 0. There's a 0 in there. If you don't have a parentheses, then inside, h was a 0. Because there's always something inside. Sometimes it's a 0. Okay, how would you know? Because there are no parentheses there. And then, plus you have a k. Okay. So do you see k is always after the square? So after the square, and it's either added or subtracted after the square. Do you see anything added or subtracted after the square? So what must have been added after the square? Another 0. So when we graph this parent function, it is actually the same as what we're going to learn how to graph. But in this particular case, the a in front of the square, it's a 1 times your square, 1 times. Inside that parentheses, because it's just x squared, the h inside there, because you don't have a h is a 0. And then because there's nothing added or subtracted afterwards, that means your k is a 0. Just like when we do an equation of a line, you want to get y by itself, so you know what m and b are. You want to find the m and the b so you can graph it. One of the things you want to do when you graph these new things is you want to know what the a and the h and the k are. If you know what they are, then you're going to know where the graph goes and how it opens and what you're going to do with it without having to plug in a whole bunch of numbers. That's the goal. Okay. So here we go. I am going to randomly just pick some numbers so we can get an idea of what this graph is going to look like. So if you're looking down right now, and then you decide to look up and go, where those things come from, I am randomly going to pick some numbers so we can make a picture. So the function is x squared. And I want to generate some ordered pairs. So I am just going to start with -3, -2, -1, 0, 1, 2, and then 3. Just so I can get an idea what this thing's going to look like. All right, so -3 goes in for x. So this is f of -3. Remember what I keep harping on. And I will continually harp on this. Whenever you substitute, try to use parentheses, especially with negatives. Negatives need a hug. They really, really, really do. Some of you lost points because you had to plug a negative into your function on the last test. You had x squared and you're supposed to plug in -10, so you went -10 squared. If you wrote -10 squared, the answer to this is -100. Because without parentheses, this is a negative and then 10 times 10. And a negative 10 times 10 is a -100. If you're supposed to replace x with a -10, that means it's a -10 and then you square it. Use parentheses. So now that's -10 times itself. That's how you get a positive 100. Okay? I make them, again, details, make a big deal about it. So when I replace the x with a -3, then I'm going to get x squared, so that's -3, and I'm going to square it. So a negative times a negative is going to be a positive. 3 times 3, this is +9. So when I plug -3 in for x, the y value is +9. Now, that's going to be off our grid. That's okay. I needed that number just to get us going. So it only goes up to 7, so I'm going to extend this up a little bit. So there's 8, there's 9. Here's -3. I'm going to go up to here. And I'm going to plot that point, and I'm going to label it. Right there is -3, +9. Then we plug in -2. F of -2. So again, I'm plugging in a negative, parentheses, -2, and we square it. So -2 times -2 is +4. So when the x is a -2, the y is a +4. So here, when we have x is -2, then this y value is up here at +4. For in pair, we label. And then we plug in -1. So that means we're going to square a -1. So again, when you square a negative, and this is going to be an important rule, an even power of a negative, when you have an even number of negatives, if you have two negatives, a negative times a negative, that's a positive. If you have four negatives, so something to the fourth power. So four negatives multiplied together. The first two, negative times, that's a positive. The second two, negative times, that's a positive. And then you multiply two positives together, so you would get a positive. If you have a power of 4 and you plug in a negative, it's positive. If you have a sixth power and you plug in a negative, it's going to be a positive. So if you ever raise a negative to an even power, the answer is a positive. Always. What are you going to get if you have a negative to a positive? You'll get a negative. If you have a negative and you raise it to the first, well, that's just that single negative, it's a negative. If you have a negative to the third, so that would be 3 negatives. So these two make a positive, and then you got to multiply by the last negative. So negative times a negative is a positive, times the last negative, positive times a negative, the answer is a negative. So if it's a power of 3, the answer is a negative. Go to a power of 4, that's positive. If I go to a 5, now I got to put 2 more here. So these two, that's positive. Those two, that's positive. And then you got this leftover, that's a negative. 2 positives, that's a positive. But then you got that leftover, that's a negative. And then a positive times a negative, negative. You ever hear the word 2's company, 3's a crowd? So when you have 2 people on a date, hey, that's great, positive. Then here comes your friend tagging along. Little brother, little sister, tag along. That positive night is now ruined, negative night. Then you have a double date. You and another couple, they go out, hey, great. Then you get that 5th wheel, tag along. Great night, horrible night. Because that 5th wheel tag along, all they do is complain how they have nobody. Right? That would be good. Can I go with you there? Things to make sure you know. All right. So -1 squared is going to be positive 1. Positive 1. So when you plug in -1, we get positive. -1 goes in, we get positive 1 right there. And then 0. So 0 squared, 0 times 0 is 0. So when 0 goes in, 0 comes out. And that's right here at the origin. And remember, you don't have to label the origin. So let's just kind of take a quick look at something. Here's what you're used to plotting 2 points and then draw a straight line. Well, if I have 2 points, are the other points on that straight line? No. If I try to draw my line through here, those 2 points are not part of the graph. If I try to draw through here, then those 2 points are not part of that line. If I even try to draw through here, then you can see if I only plot 2 points and then think I'm going to make a straight line, it's not going to include all the other points. Okay, so let's keep going. That's why you never assume. Therefore, 1 is 1. Again, even though I'm plugging in a positive 1, I don't need the parentheses. But if I use parentheses every time I substitute, it's not going to hurt. That way, I remember to always use parentheses. 1 squared is 1. 1 goes in, 1 comes out. Now, Right here, 1, 1. If you continued the pattern, you continued past tense the pattern. As we go from left to right, these y values keep going down. So we start to think, all right, the next y value must keep on going down. But as you can see, the next y value, when you get to this side, it goes up. It takes a turn. So let's see what we've done happen. 2. And that's 2 squared, which is 4. So positive 2 goes in, and we get 4. So it's right here. Red, so it's in the same column. Do you see what's on the left-hand side? At -2, we got positive 4. And then directly to the right of 0, positive 2 gave me the same y value. Left and right of 0, you have same value. That's called symmetry. What's on your left is the same as on your right. You can fold it across the y-axis and they fold up on each other. So without plugging in 3, what's the answer going to be? 9. Because over here on the left side, 3 units away from 0, the answer is 9. So that means 3 units to the right. This would also have to be 9. And you can just use symmetry because you start to see the pattern. Now, I'm perfectly fine once we get going to use symmetry. You still might have to plug in 1 number, but then you can use symmetry. 1 or 2 numbers on a parabola, but then you can just use symmetry to get the other side. So the way a graph works for x squared, by the way, x squared is called a parabola. Now, so when I was second year at UCLA, again, I thinking I was going to be an aerospace engineer. My 3rd semester calculus class was taught by Dr. Sundarar Vinduraswamy. Okay. At UCLA, no professors are from the United States. Nobody. Well, maybe. In the science and math department, very few. Everybody has an accent. The worst accent was the chemistry class I had, Dr. Farrington. He's from Germany. German was the worst accent that I struggled with. But Dr. Sundarar Vinduraswamy, Parabolas. That's how he pronounced it. There are parabolas, hyperbolas, and then you got to put the parentheses or under order pairs. The parentheses. For a week and a half, I had no idea what he was talking about. Which, if I looked at the homework, I would have known what he was talking about. Oh, parabolas, hyperbola, oh, parentheses. Yeah, okay. But I didn't know what he was talking about because I didn't bother looking, and that's how he pronounces it. I had a student teacher when I was teaching at Buchanan High School. She was a really good teacher. But you know what the Pythagorean theorem is? A squared plus b squared equals c squared. We do right triangles. You've heard of it, I hope. Pythagorean theorem. She would pronounce it Pythagorean. So all of my students are going, what's she talking about? Oh. Whatever. You're lucky I don't have an outrageous accent. I'm just speaking math. I'm giving it the accent. So I connect these dots. Sometimes you write down the jokes that hit, and now I just need to keep writing down the jokes that miss. It's a curve. Now, you can go all the way, and if you're really good, you can hit those points. But for me to hit these points, I draw the left-hand side of the curve. And because my shoulder is so bad, this is painful. And the right-hand side of the curve. Plot and label. The directions on your quiz and on your test say you must plot and label at least 3. At least 3. 1, 2, 3. That'll be good enough. On a parabola, 5 are really going to help. 5 are really going to help. Now, if you'll always be able to figure out this guy. This point right here is called the vertex of the parabola. That's the vertex. That's where the parabola changes direction. It's the bottom of a parabola. Okay? You'll always be able to figure out the vertex of a parabola because it's given in the equation. It's one of these things that are in the A, the H, and the K. So just by looking at the equation, you're going to be able to pick it out of the crowd, like a police lineup. So you know what one of the points is. To get the other 2 points, and when I say 2, you'll see in a second, you're just going to want to pick a number to the right. If I plug in 1, then the other side is going to be symmetry. When I plug in 1, the y is 1. So over here, when -1 would also be 1, since it's the same height. And then I go 1 more to the right, and I plug in 2, so that's a 4. So if I went 2 to the left, this would also be a 4 because there's symmetry across the vertex. Left and right side of the vertex. Always. That's what a parabola always looks like. A parabola, when am I ever going to have to use this? Everything that is thrown through the air, if you leave the earth, and basically, no matter what it is, gravity gravity's not a force. Gravity is an attraction between 2 masses. But anyway, the gravitational attraction between the 2 masses cause the path of the object to always go in a parabola. So when you hit a baseball, it travels in a parabolic shape. When you throw a football, it's going to travel in a parabolic shape. And when we launch a rocket, technically, now a rocket continually has force as it's driving it away from the Earth. But in order to orbit the Earth, it's trying to follow, basically follow a parabolic shape. It's fighting gravity to go up, and eventually, if you turn the rockets off, it's going to come all back down, and it's going to follow a parabolic shape. When I throw this across the room, that's a parabolic shape. The lens on your eye is a parabola. Parabolas have focal points, and light travels in parallel lines, and the parabola on your lens causes all those parallel lines to converge on the back of your eyeball where the retina is. If you're nearsighted or farsighted, that's because your lens is screwed up. And the focal point of the light is not on the retina, it's either in front of it or behind it. And that's why you have fuzzy vision. You put glasses in front of your eyes, then it refocuses the light on the retina where it's supposed to be. Same thing with contact lenses. If you hold a contact lens, that's a 3-dimensional parabola. Telescopes are parabolic mirrors. They collect all the light that's out there from the stars. Parabola down here at the bottom focuses it on one particular spot. Then you take a lens and look down, and that's your parabola. Down here, but you use a magnifying scope right here, and you look down to see a little mirror down there. I don't know if you've ever looked at a telescope, a refracting telescope. That's all about parabola. If you've ever been in a convenience store and you have the mirrors at a corner, the mirror coating is on the back side of a parabola, and that allows people to see around corners. And the equations of parabolas are a times x minus a squared plus k. In this particular problem, the a is a 1. If a is positive 1, positive, parabola opens up. Positive, it opens up like a cup. Okay? Last thing before we take our quiz. If I put a negative in front of the x squared, now remember, is it in a parenthesis? No, it's in front of the square. So when you square something, this negative right here is not getting squared. So before, the original one, just x squared, the a was positive 1. Right now, in front of that square, a is negative 1 times that x squared, negative 1 times the x squared. Look what happens to all of these answers. There would be negatives in front of the squares. So you would square the negative 3 and you get positive 9, but then there's a negative out in front. So it changes the answer of positive 9, negative out in front, it becomes a negative 9. And the answer would now be down here. When you square the negative 2, you get positive 4, but there's a negative out in front. So what comes out is now negative 4. So it's right here instead. When I square that negative 1, there's a negative out in front. So when we square it, positive 1, but then the negative in front makes it a negative 1. So it's right here. Negative 0 squared is negative 0, but negative 0 is just 0. 0 doesn't have a sign. Positive 0, 0. Negative 0, still 0. So it's still here. And then a negative times 1 squared is negative 1 because of the symmetry on the left-hand side, on the right-hand side. Plug in positive 2, there's a negative in front, so we end up with negative 4. And if we plug in 3, symmetry would be down here, negative 9. So when you graph negative x squared, instead of going up, it opens down instead. And as you can see, arrows, because it's going to keep on going down forever. Okay. And if you notice, it doesn't go like, it doesn't go straight up one of those vertical lines. It keeps going wider and wider and wider. And I'll make sure I mention something about that, because I get students that go, they make it go like this. They get a little bit of white and then they go straight up the vertical lines and now parabola. So the A, one of the things it does, opens up or opens down. If it's positive, it's like you're smiling. When you're positive, you're happy. It's smile, opens up. But when you have a negative in front, it's concave or concave down, it opens down like a frown. The A on all of those things is going to control ups and downs. If it's positive, we go up, negative, we go down. Yeah. There we go. Non-Euclideans. So whatever you're using, calculator, notes, pencil is best because you're graphing. Straight edge. Make sure you pay attention to the directions on the second problem. Whether, you're writing it in terms, what function you're writing it in terms.